Hello and welcome to the topic of Surds for our Year 9 edition. So the topic of Surds feeds in quite nicely to a range of other topics in Year 9 and Year 10 maths and even Year 11 and 12. We're going to be covering it in a nice sequential basis in this first video. So in this particular video, we'll be talking about just an introduction to what Surds are, how are they useful. So let's dive straight into it. So let's talk about the definition of rational numbers versus irrational numbers. So any number that we can write as a fraction, a over b, where a and b are integers, so they're just whole numbers essentially, we can't have b equals 0. These fractions are what we call rational numbers. So this means examples such as a half or even 2 on 3, maybe something like 123 over 241. All of these are examples of rational numbers because they can be written as fractions. Now, what about something like 21.2? You might think, well, this isn't a fraction, so it's not a rational number. But what actually happens is we can write this as a fraction. We know that 21.2 is actually the same as 212 over 10. Okay, so that just shows that even though a number might not look like it's rational, we can actually convert it into a fraction and then it can be rational. Now, a quick overview on some stuff. So here we have integers. So all integers we can say are rational numbers. So why is that? Let's say I choose a random integer such as 5. You're like, okay, how do I write 5 as a fraction, right? Where a and b are integers. Well, I can say that 5 is the same as 5 over 1. And so we can say that an integer such as 5 is going to be a rational number. We already know that all fractions are going to be rational numbers because the definition of a rational number is that it can be written as a fraction. Now, terminating decimals. So that was like the 21.2 example. We can always convert that as a fraction. And finally, we have something called recurring decimals. So you might be familiar with something like 0.333, and it just keeps going on forever. Now, hopefully you know that this can be written as a fraction. It can be written as 1 over 3. In fact, we'll cover how to write recurring decimals as a fraction in a separate video. But for now, I just want you to understand that all recurring decimals, so things that repeat after the decimal point, they are going to be considered as rational numbers. Now, that leads to the question, what are irrational numbers? Well, irrational numbers are numbers that we can't write as fractions. We can't write them as a over b. And some examples might include pi, some examples might be root 2, and other examples might be this letter e, even root 3, like heaps of examples of what irrational numbers are. So let's do a simple exercise going through the following examples, and we want to use our calculator to decide whether the following are rational or irrational. So with the first one, we have pi. Now, I've already mentioned in the previous slide that pi is an irrational number, but let's just double check that. So we can put pi into our calculator. And when we put pi into our calculator, we get 3.141592654, and it actually keeps going. It's just that your calculator normally just gives it to that many decimal places. Now, you just want to be observing for a pattern here. Are there any patterns? Because remember, recurring decimals are going to be rational. But you can see there is no sense of having any recurring decimals. So in that case, we're going to say that this is going to be irrational. Now we look at root 9. Now, hopefully you know that 9 is a perfect square. So if we write root 9, we can actually just say that is the exact same as 3. Now we know 3 can be written as a fraction, right? It's an integer. So we can say that 3 can be written as 3 over 1. And so therefore, we can say that 3 over 1 or root 9 is going to be a rational number, okay? Now we move on to something like root 10. So if you put that into your calculator, it's going to spit out a number that looks like 3.162227766. Now, it's going to keep going, but like I said, our calculator only goes to that many decimal places. Now, you want to look for any repeating, like any sense of repeating decimal places. And from the look of it, we can't really say there is. So automatically, I'm going to be thinking, okay, well, it's going to be an irrational number. In fact, I might as well say this now. The idea of an irrational number, if you're square rooting a non-perfect square number, then you're going to be getting an irrational number. So stuff like the square root of 81, well, we know that's 9, so that's going to be rational. But if I did the square root of 82, 82 is not a square number. So I'm going to get an irrational number, okay? So that's one quick way of differentiating it straight off the bat. Now let's continue. So using that same logic for number 4, we have the square root of 89. Now the square root of 89, well, 89 is not a square number, so we can automatically say it's irrational. And you can use a calculator to figure it out, but it's going to be equal to 9 point something. So irrational. Now, we move on to question 5. So we have the square root of 5 squared plus 12 squared. Now, hopefully you remember from the Pythagorean triad videos that we have a triad 5, 12, 13. If not, go check that out. But basically, this is actually going to equal 13. You can put this in your calculator and verify that. But if we know that this is equal to 13, well, we know it can be written as a fraction, as 13 over 1. And so we can say that it is a rational number. And finally, we have number 6. We have square root of 5 squared minus 3 squared. So if I put this into my calculator, that is going to give us 4. And so we know that 4 can be written as 4 over 1. And that is going to be a rational number. So hopefully you've got an understanding of what kind of numbers are rational, what kind of numbers are irrational, and we will build this up as we go through the slides. So that's the end of our first video on the Year 9 Surds series. Next video, we'll be talking about how to prove that root 2 is irrational. And then after that, we'll be looking at more videos talking about the addition and simplification of various different surds. Hope to see you in the next one.